Hello and welcome to day 2 of your Python journey. Yesterday we learned how to print text and take input. Today we're diving deeper into data types, operators, and some cool tricks with strings. By the end of this video, you'll build a simple BMI calculator and a string reverser, both using just what you learned today. Let's begin. Python uses different kinds of data to represent information. Let's break down the 4 main types. First, we have integers. These are whole numbers like 10, 20, or -5. Second, we've got floats, numbers with decimals like 3.14. Third, there are strings, which simply mean text, anything inside quotes. And fourth, the Boolean type, which can only be true or false. Now let's see what happens when we assign these values in code. Did you notice? Python tells you the type of each value using the type function. That's how we know what data we're working with.
Here is a simple Python script demonstrating basic data types. First, we assign the value 10 to the variable x. Since it's a whole number, Python treats it as an integer. Next, we assign 3.5 to y, which has a decimal point, so Python classifies it as a float. Then we create a variable name and assign it the text vivic, which is a string. Finally, we have a Boolean variable called isPythonFun set to true, representing a truth value. Now, when we run the program and print the type of each variable, Python outputs the data types. We see that x is an integer, y is a float, name is a string, and isPythonFun is a Boolean. This simple example shows how Python differentiates between common data types.
Now that we have data, let's do something with it. Here are the basic operators in Python. Addition is plus, subtraction is minus, multiplication is the asterisk, division is a /. Then we have modulus, which gives the remainder, using percent symbol, floor division, using 2 slashes, it gives whole number result, and exponentiation using double asterisk to raise to a power. Let's try a few examples in code. First, we set a equal to 10. Then we set b equal to 3. Now we use print statements to show the results of different math operations. We add a and b. We subtract b from a. We multiply a and b. We divide a by b. We get the remainder of a divided by b. We do floor division, which gives only the whole number part of the result. And finally, we raise a to the power of 3. 10 plus 3 is 13. 10 minus 3 is 7. 10 multiplied by 3 is 30. 10 divided by 3 is 3.333. The remainder when 10 is divided by 3 is 1. Floor division of 10 by 3 gives 3. And 10 to the power of 3 is 1,000. Easy, right? These are like your calculator buttons, now in Python. You already know that input lets users type something in, but did you know everything input gives you is a string, even if it looks like a number? So if you want to add numbers, you have to convert the string into an int or a float. Let's try that with age. All right, let's walk through this simple Python program that handles user input and performs a small calculation. First, we use input
to ask the user to enter their age. This input is always treated as a string, no matter if the user enters a number. So when we print it using print, age type age, it shows the value along with its data type, which will be class string. But to do math with age, like adding 5 years, we can't use it as a string, so we convert it using int age. This changes the value from a string to an integer. Then we print a message showing the user's age 5 years from now using print, in 5 years you'll be age plus 5. Now, let's run the program and see the output. Let's say the user enters 25 as their age. The first output will be 25 class str. This confirms that the input is treated as a string by default. After converting it to an integer, the next line prints, in 5 years, you'll be 30. This is the result of adding 5 to the age after conversion, because now it's an integer and can be used in arithmetic operations. That's how you go from input to actual logic. Now let's play with strings. If you want to combine strings, you can use the plus sign. But there's a better way. It's called f-string formatting. Just write an F before your string and use curly braces to plug in values. This makes your print statements clean and powerful. Let's build our first mini project, a BMI calculator. Here's the formula. BMI equals weight divided by height squared. We'll ask the user for weight and height, do the math, and format the result. All right, now let's jump into something practical. We're going to write a simple but really useful Python program that calculates your BMI, body mass index. It just takes a few lines of code, and I'll walk you through each part step by step, explaining everything clearly so you don't miss a thing. First, we need to get the user's weight. We're using the input function here, which takes input from the keyboard. Since input returns data as a string by default, we convert it to a float using the float function. This is important because someone might enter a weight like 68.5 kilograms, and we need to handle decimal numbers. Next, we ask the user for their height in meters, again using input, and convert it to a float for the same reason, to handle decimal values like 1.75 meters. So now we have both weight and height stored as floating point numbers. Now we calculate the BMI using the formula weight divided by height squared. In Python, to square a number, we use 2 asterisks. So this line means we divide the weight by height times height. Finally, we display the result using a print statement. Here's something new. We're using an f-string, which is a powerful way to insert variables directly into a string. Notice the BMI :.2f part. This is formatting the BMI value to 2 decimal places. The :.2f means floating point with 2 digits after the decimal. This helps keep the output neat and easy to read. When we run this program, Python will ask us to enter our weight and height, and then it will calculate and show our BMI rounded to 2 decimal places. Let's go ahead and try it. Let's say I enter my weight as 68 and my height as 1.75 meters. The BMI will be calculated and shown like this. Your BMI is 22.20. That's a healthy range. So that's it. You've just built your own BMI calculator in Python in less than 5 lines of code. You learned how to get input, convert data types, use mathematical operators, and format output using f-strings. Next, let's reverse a string. It could be a name, a sentence, anything. Python has a super easy way to do this using slicing. Just type string, open bracket, ::(-1), close bracket, and boom, it's reversed. Okay, let's write a program in Python that takes a word or sentence from the user and prints out the reversed version. We'll write this step by step inside Visual Studio Code, and I'll explain everything clearly as we go along. Let's get started. In this program, we will take a word or sentence from the user and reverse it. Let's begin. First, we ask the user to enter something using the input function. The line of code is text equals input
open parentheses, quotation mark, enter a word or sentence, quotation mark, close parentheses. This stores the user's input in the variable named text. Next, we reverse the input string using slicing. The line is reversed underscore text equals text, open square bracket, colon, colon, -1, close square bracket. This is a slicing technique in Python. The colon, colon, -1 tells Python to go through the string from end to start, reversing it. Finally, we print the result using print, open parentheses, quotation mark, reversed colon, quotation mark, comma, reversed underscore text, close parentheses. Now, if you enter the text, Vivek S. Sankar, S, the output will be S space RAKNAAS space KEVIV. Pretty cool, right? This is how Python makes string manipulation easy. Try running this code on your own and see what happens when you reverse other words or phrases.
Magic, right? Let's quickly recap what we learned today. Data types, int, float, str, and bool. Operators for math and logic. Input and typecasting. String formatting and manipulation. And 2 practical projects, a BMI calculator and a string reverser. Your homework. 1. Create a program that asks for your name and birth year, then prints your age. 2. Build a calculator that asks for 2 numbers and prints their sum, difference, and product. Tomorrow we explore if-else statements and logic. That's where decisions come into play. Until then, happy coding.